7.2 Experimental and Theoretical Probability. Experimental probability is based on repeated trials of an experiment. So you actually have to do the experiment to calculate the experimental probability. Okay, so the formula for calculating the probability of an event is taking the number of times the event occurred and divided by the number of trials you conducted. So, for instance, in this experiment here, we flipped a coin and we flipped it 25 times and we recorded how many times we got heads and how many times we got tails. So, if we want to calculate the experimental probability of spinning a head, so probability of heads is the number of times the event occurs. It occurred 6 times. And we're going to divide it by the total number of trials, which is 25. And 6 over 25 is the same as 0.24, which is the same as 24%. So the experimental probability of spinning heads in your experiment is 24%. Okay, so now you need to write in your notes, and there is one section on experimental probability. Okay, now that you finish that, there's another type of probability you want to talk about, and that's theoretical probability. And this is when all possible outcomes are equally likely, and the theoretical probability of the event is calculated by dividing the number of favorable outcomes by the number of possible outcomes. So, for instance, let's say we have these blocks here, and we want to choose a vowel. So we want to find the theoretical probability of choosing a vowel from these blocks. So in order for us to calculate the theoretical probability of choosing a vowel, we need to take the number of favorable outcomes, which is our E, our O, and our E. So we have EOE, which is 3 outcomes, and then divided by the number of possible outcomes. So how many blocks do we have? 1, 2, 3, 4, 5, 6, 7. So this then, 3/7 is also the same as 0.43, which is in percentage form, 43%. So our theoretical probability that we pull a vowel from these blocks is 43%. All right, now you get to write in your notes about theoretical probability. Okay, we can use both theoretical probability and experimental probability and can compare them. So let's take a look at this experiment that we conducted when we rolled a die or a cube 300 times and we recorded how many times we got a 1, 2, 3, 4, 5, or 6. Okay, so this is our frequency of getting those numbers on the die or cube. So we want to see how our experimental probability actually relates to our theoretical probability. So to find our experimental probability, we need to take the number of times. So let's go P. So we're going to find the probability of rolling an odd number. So we need to take the number of times we rolled an odd number, which was 1, 3, and 5. So if we add up 48, 50, and 49, so 48 plus 50 plus 49, that equals 147. Okay, and the total number of times we rolled was 300. So our probability then ends up being this over our total. So 147 divided by 300 is approximately 49%. Okay, now to find our theoretical probability. So what are our numbers on our die? We have a 1, a 2, a 3, a 4, a 5, and a 6, right? And our odd numbers are 1, 3, and 5. So we have how many favorable outcomes? P odd. Number of favorable outcomes is 3, right? 1, 2, and 3. And how many possible outcomes do we have? Well, 6. So this is the same as 1/2, which is the same as 50%. So our experimental probability of rolling an odd number shows us that it was approximately 49%. But in theory, our theoretical probability says that it should be about 50%. So our experiment was fairly close to the theory. Okay, and one last thing, we can use experimental probability to help us to make predictions. So for in this example here, we have a bag that has 50 marbles, and we randomly choose a marble from the bag. We record its color, and then we put it back in the bag. Okay, and we did this 50 times, and we recorded each time. Actually, we did this 30 times and we recorded each time. So we want to use our experimental probability to predict the number of red marbles in the bag. So let's find out our probability of selecting a red. Okay, so how many times did that occur? 9. And how many draws did we do total? 30. Okay, so 9 over 30 is about the same as 3 over 10, which is the same as about 0.3, right? 30%. Okay, 30% of the time, we were able to draw a red marble. So if we want to predict the number of red marbles in the bag, we would just take the number of marbles in the bag, which is 50. We know there are a total of 50. And then we want to multiply it by our experimental probability of getting a red, which is 30%, which means that we predict there are approximately 15 red marbles in the bag. Okay, and now we are just going to do 1, 2, 3 practice problems. Okay, for the practice problems here, we have this table that shows the result of us doing an experiment. We rolled a die 50 times, and we recorded how many times we rolled a 1, 2, 3, 4, 5, or 6. Okay, so now we want to calculate the experimental probability of rolling a 3. So the probability of rolling a 3 is how many times did it occur? 8 times, that was the frequency. And how many rolls did we do altogether? 50. So what do you think the experimental probability of rolling a 3 is? Okay, next practice problem. We're going to now try to calculate the theoretical probability of randomly choosing the letter X from this group of letters. Okay, so probability of selecting an X. How many X's do we have up here? We have only one. How many blocks do we have? 3, 6, 7. So then our theoretical probability of randomly choosing an X is what? And the last one, we have an inspector who selects 200 pairs of jeans and finds 5 of them are defective. Okay, so how many pairs of jeans do we predict would be defective in a shipment of 5,000? Well, let's first find out what our experimental probability was of finding a defective pair of jeans is. Okay, how many did we find? We found 5 out of a sampling of 200, which is the same as 1 over 40. Okay, so 1 out of every 40 we think are going to be defective. So if we then multiply this times our shipment of 5,000, we'll be able to predict how many we think will be defective in this shipment of 5,000. So what's 1/40th times 5,000? And that's your answer. And that concludes 7.2.